So I want to talk a little bit about scatter plots. So as discussed in other lessons, a scatter plot is basically a graph that helps you to see relationships between two variables. So because we have lots of data points that don't always necessarily fall in line with each other, we don't usually join them together. So what we're seeing here is a bunch of data gathered over time about the average daily temperature, and we looked at how many visitors would visit a beach depending on the temperature. And so when we look at this, we can see that there is a relationship because these points are all sort of gathered and they form a trend. And we'll talk more about types of trends in a bit. So some notes about graphs. Remember that the spacing between the tick marks on the graph, in other words the scale, have to all represent the same amount. So in other words, looking at my horizontal axis here, go 80, and then this right here must have to be 82, so that means that the space between tick marks is 2 here. And again, 82 to 84 is a jump of 2, this is 86, 88, and so on and so forth. So I can't just choose whichever values that I want to create my scale, the ones that are my data points. I have to just make equal intervals as I go up. So let's interpret this graph. So what this graph is telling me is that as the temperature increases, there are an increasing number of beach visitors. So why is that a relationship that makes sense? Well, it makes sense that if it's nice outside, you're going to see more people visiting the beach. And as it gets colder, less people are going to want to be at the beach because it might be too cold for them. Most people like to go to the beach when it's a nice, hot, warm, sunny day, either to tan or to cool off in the water. So when the points sort of form a pattern like we see here, we can say that a relationship exists. So I'm going to give you a couple of examples here. I've drawn this line here to demonstrate the trend, but I'm going to show you a different one. So in the second example, I can see also that the data points on my scatter plot seem to form a straight line. So this is also a linear relationship, but it's a different type of relationship than what we saw before. In this case, we see the dots sort of starting high and going low. That's what we call a negative correlation. And so let's examine why that makes sense for this particular set of data. So it looks like they've polled people of different ages from starting maybe a little bit around 10 and all the way up to beyond 60 years of age. And what they did was they asked them, well, how many hours of video games, or minutes it looks like, minutes of video games do you play in a day, daily amount? So it seems as though, the younger you are, right, the lower your age, the higher the amount of the number of minutes that you're spending on video games. And I think that makes sense because as you get older, things happen to your life that mean that you can't or aren't interested in playing video games anymore, right? It could also be a function of the fact that in our, the older generation maybe isn't as familiar with video games. So that's an example of a negative correlation or a negative relationship. Okay, so sometimes when you plot a bunch of data, you can see that there's actually no relationship whatsoever between the two variables. Sometimes it's obvious if you look at it, but sometimes you're not able to see if there's a relationship until you actually plot the data. So let's look at this situation here. All these data points are randomly located. And when I look at trying to make sense of this, I'm going to look at the variables. So what they're saying is does IQ depend on your shoe size? Well, I think most of you know that your shoe size has no bearing on your IQ value. So it makes sense in this case that we would expect that there'd be no relationship that would be evident. So this is an example of a no correlation or a zero correlation. So let's put all of that together. So correlation is basically a fancy word used in math that really means the same thing as relationship. Okay, you can even see the word relation in there. So a negative correlation exists if you see that the points start high and start to go down. So we say that that is a decreasing function. It decreases as we go from left to right. A positive correlation over here, we call that an increasing relationship. And because we see that as the values for my x-axis increase, so do the values on my y-axis. Okay, I see that from left to right, the values are increasing. And of course, I can see that there's no correlation at all if my data points when I plot them are sort of all over the place. So let's look at some other examples. So in this first example, I see a negative correlation. My data points seem to form a trend. And what I'm looking at here is auto mileage, so the number of miles in this case that have been used on a vehicle, and the value. So let's think about that in terms of our lives, right? The longer, this is saying is the longer you drive your car, the lower its value becomes. And I think that that makes sense. The older the car, usually that means that you've driven it for longer, and its value is going to go down. Over here on the positive one, okay, the number of auto accidents, we're looking to see how that depends on the cost of insurance. Well, I can tell you that when I was in my 20s, I totaled a vehicle, and when I did that, I ended up having to pay $600 a month in insurance. And now, as a 42-year-old woman, my insurance now is down to about $60 a month. So definitely, the more accidents you have, the higher your insurance is going to be, right? So that makes sense that it would be a positive relationship. As the accidents increase, the number of accidents increase, my insurance cost is going to increase as well. Okay. And then lastly, zero correlation here, and let's see why that makes sense. So I'm looking at the auto quality. Okay, so that means that, how well it's made, versus the auto body color, so the color of your vehicle. Now it makes sense that there wouldn't be a relationship between that, because there's some very well manufactured vehicles that have a terrible color, and there are also many vehicles that are poorly made that have a really nice look to them in terms of their color. So there's a few examples. So remember, when you're looking at a negative correlation, you're looking as one of the things increases, the other variable is decreasing. For a positive relationship, as one of the variables is increasing, the other one is increasing as well. They're doing the same thing is going on. And zero, you can just tell that really the variables have nothing to do with each other. One is not having an impact or effect on the other. All right, so let's go through some examples not looking at graphs. So let's read the question and then take a look at it. So identify whether each of the following variables, sets of variables, would have a positive, negative, or no correlation. All right, so A says salary and years of experience. Well, I mean, it's tough to know. It's different in every job sector, but if you had to make your best guess at this, it would make sense that as the salary is increasing, as your years of experience go up, so will your salary. So they're both sort of moving in the same direction. As one increases, the other one is going to increase as well. So I would say that this is definitely a positive correlation. So I'm going to write positive. Right, and so looking at the next example, the number of flu shots given and the number of people who get the flu. Well, I know that the greater number of flu shots are given, the less people there are likely to get the flu, right? So I would give flu shots out so that we reduce the number of people actually getting the flu. Now, whether that holds true or not is, that's up to the researchers to tell us, but it seems to me that that would be a negative relationship. So because the whole point of giving the flu shot is to reduce the number of instances of the flu. Okay, so I'm going to call that a negative relationship. Eye color and IQ. Well, I mean, I know lots of different people who have a variety of different eye colors, and it really has nothing to do with their inherent ability to think or to work through things. I think we're all gifted in different ways, but our eye color certainly has nothing to do with it. So to me, that is definitely a case of no or zero correlation. If you have any questions at the end of the video, make sure that you ask me to clarify. If you need to watch this video again to help your understanding, make sure that you do that.